All right, our next example for finding the derivative is what I've given you here. It's x divided by the square root of x, 2x squared plus 3x. So before I take the derivative of this, I mean, I could use the quotient rule with it, but I'm actually going to rewrite this as x multiplying 2x squared plus 3x to the exponent negative a half, just to slide that up to the top and to change that square root sign into an exponent of a half. The reason I do this is because the quotient rule, it works, but we know it is a little bit tedious. The product rule is a bit easier to use. So by expressing this as the product of the x times this other piece, I find the derivative is actually a bit easier than using the quotient rule. All right, so using the product rule then, the derivative of the first is just a 1 times the second, 2x squared plus 3x all to the exponent negative a half, and then plus the derivative of the second. So using that chain rule, that negative a half exponent comes down front, negative a half exponent comes down front, and then we write what's inside that bracket and then reduce that exponent by 1. So that negative 1/2 now becomes a negative 3/2, and then times the derivative of what's inside, which I believe should be 4x plus 3, and then times the first. Okay, so hopefully that's your first step, as it is my first step. Now I'm going to look at starting to factor some things here. Now I notice that I have this bracket of 2x squared plus 3x. 2x squared plus 3x appears in both pieces. My lowest power of it is right here, because negative 3/2 is actually smaller than negative 1/2. So when I go to factor that, I'm going to factor out 2x squared plus 3x to the exponent of negative 3/2. Okay, now to do that, in this very first bracket or first term, of course I have 1, which I don't need to write because that's not going to change anything. To make that turn into an exponent of negative a half, I would multiply it by 1 power of that. So I'm going to have a power of 2, or a factor of 2x squared plus 3x. Okay, and that's just to the exponent of 1. I don't have to write that exponent 1 there, but I'm just going to remind you, because negative 3/2 plus 1 whole would be plus 2/2. That would equal your negative 1/2, which is what you want to have to match. All right, for the next part, I'm going to have a negative a half. I'm also going to have, I'm going to pull that value of that monomial x to the front with that. My factor of 2x squared plus 3x all to the exponent negative 3/2 has already been pulled out, and then we just need the factor of 4x plus 3. Okay, from here I am going to expand and simplify some things. I'm going to keep that factor of 2x squared plus 3x to the negative 3/2 here for now. And then I am going to expand and simplify what I have in the brackets. 2x squared plus 3x minus, and then a half of 4 would be 2 with an x squared, and then minus a half of 3 would be minus 3/2 x. All right, continuing on here. 2x squared plus 3x to the exponent of negative 3/2. And then we've got 2x squared minus 2x squared. They're going to cancel out. 3x would be the same thing as 6x over 2. 6x over 2 minus 3x over 2 would leave us with 3x over 2. All right, so now we're ready to tidy this up. So the 2 down is already on the bottom, and this I'm going to slide down to the bottom as well. What I'm left with on the top is a 3x. I'm going to pull that constant of 2 out front, and then you can either put this in root form or leave it as its fraction form for the exponent, which I think I will do. But if you check with Bob and Bob has it in root form, then you'll just take it back into its root form. But that would be my simplified form for that one. All right, let's try another one here. Our last example is here, y equals the square root of 3x take away 5 all over x squared minus 1, and that whole thing is being square rooted. So before we take the derivative, I'm going to rewrite that to make it a little bit easier to work with. So that I can use that chain rule. That 3x minus 5 is really going to have an exponent of 1/2 on it, as is the x squared minus 1. It also has the exponent 1/2 because that square root applies to both the numerator and the denominator, which then I'm going to rewrite as a 3x minus 5 to the 1/2 multiply by x squared minus 1 to the negative 1/2 to move that up to the top. And then I can again avoid that product or quotient rule. I can just use the product rule, which is a bit easier to use in the end. All right, so now I'm ready to take the derivative. I want the derivative of the first, so my first term's right here. I'm going to apply that chain rule. I'm going to bring that 1/2 down front, leave what's inside the bracket for now as it is, reduce that power by 1, so that becomes a negative 1/2 times the derivative of that inner function, the derivative of what's inside, which is a 3. So there's the derivative of the first times the second. And then I need to add the derivative of the second. So the second one is here. Again, I need to apply the chain rule. So that negative 1/2 is going to come down front. It's going to multiply that base, but its power, its exponent, will be 1 less than negative 1/2, which will make that 3/2, times the derivative of the function inside, which would be 2x, times the first, which is the 3x minus 5 to the 1/2. All right, now I'm going to look for what each of the two terms have in common with each other, and I see that both have a factor of 1/2. Both of them have a 3x minus 5. My lowest power of that is to the negative 1/2, and they both have an x squared minus 1, and the lowest power of that is the minus 3/2. So when I do my common factor for this, my common factor I'm going to use will be 1/2. I'm going to use the 3x minus 5 to the negative 1/2. Always choose your smallest power of a factor when you common factor it out. Times x squared minus 1 to the negative 3/2. And then I need to see what I need to multiply that by. So looking at that first term, the 1/2's already there. That is good, that's the same. I have an extra 3 in this factor right here, and I need to multiply that by 1 factor of x squared minus 1, so that would increase my exponent to be a negative 1/2 there. Then I'm going to have a minus, because overall this was add a negative, a minus. I already have the x squared minus 1 to the negative 3/2. I need an extra factor of 2 and an x, so I've got to pull this up, a 2 and an x, and I need to multiply that by 1 factor of 3x minus 5 to make that a positive 1/2 exponent when we expand that. Whew, okay, now let's see. I'm going to leave this front part here, the common factor part here for now. It eventually will slide down to the bottom. I could have done that on this line, but yeah, we'll save it for the next one. What can you do? But I am going to tidy up this bracket in here. I'm going to have a 3x squared minus 3 minus 6x squared plus a 10x. All right, so let's tidy up that part in that square bracket, and that's our numerator for our next line. So we're going to have a minus 3x squared. We're going to have a plus 10x, and my dog wants out of the office. I think she's gotten bored here. So that's my numerator. My denominator, the 1/2, will just be a 2 on the bottom. We'll have our 3x minus 5 to the positive 1/2 now that it's slid down to the bottom, and our x squared minus 1 to the 3/2, positive 3/2 on the bottom now. And I think that numerator is going to factor. First of all, I could take a negative out. We're going to get a 3x squared minus 10x plus 3. And that's going to be over the 2 times the 3x minus 5 all to the 1/2 times the x squared minus 1 to the 3/2. and that trinomial on the top does factor, and I would have a 3x. I'd have to multiply it by an x to get the 3x squared. I'm going to multiply the 3x. I need a minus 9, so I'm going to make that a 3 and a minus 1. So I'm doing a guess and check with that. I knew it would factor because of looking for the two numbers that would multiply to minus 10 in the center, and or sorry, add to minus 10 in the center and multiply to 9 on the outsides. But then I just used my guess and check to make that work out. And this should be your final form here. And I have a little extra mark that I'm going to try and, oh, apparently I can't get rid of that mark. Okay, and you can't even see me doing this probably because it's going to overwrite it. But I think that's what we have there. So this is a times sign right in between. Okay, hopefully that makes sense.